Bless you. Bless you. That would be kind of bouncing around. So on this one, I want you to realize it kind of jumps out at you why this one has to be treated differently, because I don't have any extras, do I? I've only got 2 signs. So what I want to use then is that last identity. I can't shuck something off and rewrite the rest of it, because the rest of it will now be an odd power. It's not going to go with the identity well, right? So there's got to be another way to do this, and there is. So the identity on your paper, that last, and again, if they're both even, you're going to run into this problem. Where does that really come from? And what's going to maybe throw us off here is there's already a 2 theta in there, but we shouldn't let that throw us off. I don't know if you guys remember, like, sine 2x. How can you rewrite sine 2x or
Sine x plus x.
Say again?
2 times sine.
Yeah, 2 sine x cosine x, right? How can you rewrite cosine of 2x, who remembers? I love it. Cosine squared minus sine squared. That's where I start too. It's kind of, and again, these are really built off of the addition subtraction formulas for sine and cosine. That's how you build these. Since cosine squared is 1 minus sine squared, this could also be this, which could also be that. You're like, okay, Jeff, whatever you want to say. So see, if you solve this one for sine squared, you get that identity that's on the paper, don't you? So that's really where that identity comes from. It's just this identity solved for sine squared, right? Notice, shoot, where'd it go? Oh, sorry. Notice how the sine squared is the one that's got a minus cosine, and the cosine squared is the one that's got a plus. It's kind of easy to remember, possibly. I just remember the sine is the minus in there because it's not the same as the cosine. Cosine is the same as the cosine. It's got a plus in there. So if I rewrite that using that formula, so now I've got this general formula is sine squared x. If I solve this, I get 1 minus cosine 2x over 2. Right? So what's sine squared 2x, or 2 theta? Let's do it the same way. Sine squared 2 theta.
2 sine x.
Now, careful.
1 minus cosine 4 theta.
Beautiful. 1 minus cosine 4 theta over 2. It's just substitution, right? Whatever the hell that is, it goes right there. So that's 2 theta, it goes right there. Twice 2 theta, 4 theta. Don't let it be more than that. That's all there is. So now I can rewrite the inside like this. And integrating cosine 4 theta is easy. That's the whole point, right? Personally, I always write the 1/2 on the outside. These are in parentheses now. Or you can change your limits if you like to do that. Let me go back to my marker that's working. So we rewrite that as this, 1 minus cosine 4 theta. And I just took the 1/2 out front. Is that cool?
The 1/2 came from.
Out front. From here.
Just the 2. Oh, 'cause we need the 2.
Yeah, we need an over 2, so I just put it out.
And why do your intervals flip?
I personally, I just leave my limits the same, and at the end I just go back to the original. Or did I actually? I didn't do it. I'm being silly. I don't have to change these limits. Did I actually do any substitution? No, I just rewrote it. I'm being overly careful. I didn't do any substitution. I have to change the limits. We can leave them the same anyway. The integral now should be easy. Right? The integral of 1 is theta. Cool. Minus, what's the integral of cosine? Sine. But what do you have to put in there to kill the thing that would come out? Beautiful. So over 4. From 0 to pi over 2. Like this, maybe. And then you just plug and chug, right? A 0, if I plug a 0 in those, they both die, right? Sine is 0, 0. 0 is 0. So I don't have to worry about pi over 2. I get pi over 4. And what's 4 times pi over 2 is?
2,
4 times pi over 2 is 2 pi. And what's sine of 2 pi?
0.
0. So you just get pi over 4. Can you check that somehow? Do you guys know how to use your graphing calculator to do integrals? Really? Who's got the graphing calculator with them? Anybody? So if you just put this function, sine squared 2x, into y equals. If you don't have your graphing calculator, just try to remember what I'm saying.
Integration or sine square only?
No, just put sine squared 2 theta into y equals, because one of the things you can calculate, so if you do second trace, that's how you get up to calculate, right? Yeah. Remember that when you get up to calculate, you can do the x value, you can do whatever. At the very bottom, number 7, I think, is an integral sign. Kick ass, so hit number 7. So plug that sine squared 2 theta, plug that into y equals. Second trace to get into calc, number 7 is the integral, and then it's going to ask you x equal what, and you just type in a 0. From 0 to x equal pi over 2.
I'm trying to find the trace. So 7.
I'm trying not to put it up here. So in y equals, put the sine squared of 2, and of course, how do you put that in there? Maybe I should put it up here.
You should
You have to
Jeff,
put sine 2x in parentheses and a square.
I'm kind of surprised you guys who never showed how to do that.
No.
Oh, like there. Okay, that's
Like sine twice.
square out. But it's asking you, oh, just push it. It's like a question. Right now, the limit is just 0. You want to say 0. Oh, 0. 0. We want 0 enter.
No.
Somebody grab the lights for me. Thanks, Colin. Okay. And then your blood. Okay. So in y equals, we put the actual function we're dealing with. So that's just, you're going to have to put in there sine of 2x squared. Now, if you graph it, there it goes, right? If you hit and if you want, you get zoom 6 to make sure that you're in a nice standard window, right? Zoom 6. Hit second trace to get up into calc number 7. Of course, it only does definite integration. You'd have to get a much funkier calculator to do symbolic integration, right? But number 7, and it says lower limit 0, upper limit pi over 2. 0.78539, and then what do we get? Pi over 4, and what's pi divided by 4? Blah, 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 blah. They got it, right?
How do you get that range?
Some of you guys didn't know that.
No idea.
Anybody not know that? I mean, that's freaking useful as hell. Wouldn't that have been nice to know in Calc 1? Too bad you didn't take me for Calc 1. That's all right. Because that, I mean, you get to a point in Calc 1, you want to be able to check yourself. And there you go. You got a way to check yourself on a nice function. You can. So on a test, feel free to check yourself. I don't want a number coming out of nowhere, but you can check your work. I mean, why not? Okay. All right. Let me think of anything else. It was really nice. I don't. You can't really see it too well, but it actually shades in the area you're talking about too. So it's kind of nice. You just way to double check. You put in the right limits. Okay. All right. So bring the thanks, maybe. Let's see, what do we got? We got number 26 here left, right? Now, and again, I don't like memorizing things because my brain mixes stuff around and then I kind of lead myself off the right path. If you just look at that, and you know your two main options. Your two main options are secant squared comes off or one of each come off. Which one totally doesn't make sense? One of each, because then I'd leave behind cubes which wouldn't work with the identities. Right? So obviously I don't want to do that. I want to pull a couple secants off, which means I want to let u equal tangent, because that's its derivative is secant squared. That's what you go through, and that didn't take very long. Much better than trying to memorize all this crap. But again, if you like memorization, feel free. I have nothing against you. So again, I take off, what did I just say? Yeah. Take a secant squared off, which means what do I have to rewrite? One of what? I want u to be tangent. So I want everything in terms of. Oh yeah. So you have to rewrite secant squared. Sorry, I think the medication's kicking in. So this here will be
1 minus tan squared.
yeah, because tangent squared plus 1 equals secant squared, right? So you gotta be careful. Don't overthink it. Tangent squared plus 1 is secant squared. So tangent squared plus 1. It's the secant squared minus 1 is tangent squared, right? So that's yeah. Then I got my tangent 4, and I got my secant squared theta just waiting. So now I let u equal tangent. Du is my secant squared that I pulled off of there. So I get u squared plus 1, u to the 4th du. You start to realize, I mean, you get basically all these polynomial answers, right? If you do this in Wolfram Alpha, I think there are power reducing identities. Some of you guys might remember power reduction identities. It uses those, so the answers in Wolfram Alpha will not look like what we get because it goes further.